There's no light duty on the Delaware-Lackawanna.
Oh, no.
Anyway, my name's Don Colanes. I'm the Vice President of Mechanical for Genesee Valley Transportation. They're the parent of the Delaware-Lackawanna Railroad. This is a pretty brand new shop. It's about a month old. We're still moving in, and as Pat and I were talking about, it replaced a woefully inadequate facility at Southside. So we're excited to get going here, and we have a fleet of 35 engines, and they all come here for major service. And this is it. So I'll be happy to show you anything you like. I was telling Jerry that, you know, I answer a lot of questions. Feel free to ask questions instead of me just going on, and, you know, I'll be happy to do that. But here they are. Our locomotives are Alcos, built by the American Locomotive Company. They're pretty old. This is the oldest group, 1952. And the group down there is in the 60s. But they have to work, and they have to earn their keep. So I don't know if you want, should we go up and look at one and show you some stuff? Come on down here.
Yeah.
This is the inspection pitch. Locomotive has to be inspected once a day, once a calendar day, and you know, check the oil, the brakes, so forth. And then every 90 days, the locomotive has to come in for a test. You have to check the brushes, the wheel thickness, the diameter of the wheel, check the running gear for anything that's broken or missing, check the coupler, all the hoses, lights, leaks in the engine, tune it up if it's required, fix the glass. So there's a lot going on, and locomotives are a pretty complicated system. They're like little babies. They need constant attention, you know. So this is where we do the undercarriage work. Then on this track, which we're just getting to, this is where we would overhaul an engine. And this one's in progress. If you want to look down here. This is an Alco 251 engine. And 16-cylinder, 2,500 horsepower. A turbocharged, single-acting, solid injection diesel engine. Now this engine's getting new fuel pump supports, new pistons, rods, and new cylinder heads, and new main bearings. This engine probably has probably about 5.5 million miles on it. So they have long lives, you know. And as some of you guys probably, Pat, you probably saw the 61 running here, what, how many years? It was new here in 1964.
Yeah, lots.
So, and we can fix anything here. We can do anything except turn the crankshaft and rewind an armature. I have competent guys. We're good at fixing anything here. So this is really nothing. This is kind of routine. Most of the times a locomotive is taken out of service for engine work when oil consumption is too high. Sometimes you might see oil running down the side. Can't have that. It's time to overhaul the engine. So.
Doc, can you still get parts for the Alcos, or do you have to fabricate a lot of it?
No, they make everything. I get that question a lot, Pat. Alco's still in business. They don't build locomotives anymore. You know, Fairbanks Morse owns them. There's a lot of aftermarket people, just like in the automotive business. So, and a lot of the OEM manufacturers to Alco are still in business, like Hayden piston rings, Amoeba bearings. It's all the stuff is pretty easy to get.
Cool.
Like here's I don't know if you want to take a look at this here. Well, this is pretty heavy. This is a rod. This probably weighs about 150 pounds. The engine turns at 1,100 RPM. This is a pretty, Alco's a high-speed engine. I mean, for this size diesel engine, that's pretty fast. So I always thought that was interesting. Like, wow, 1,000 RPM, and those parts going up and down. Wow. This is hard to see. Here's the fuel pump support. When I said that the engine was solid injection,
come past you. Come past so they can see.
You'll notice there's 3 lobes on the camshaft. The center lobe operates a huge injection pump that's timed and you adjust the rack, and that just hydraulically shoots the diesel fuel through an injector, and it sprays right in the engine. Fuel oil supplied like at 40 pounds per square inch to the injection pumps, and then that probably comes out around 2,500 psi. And then that box on top, that's the dynamic brakes. That's the $20,000 option. Locomotives, as you know, have air brakes, but some of them have dynamic brakes. The traction motors, which are down here, turn into generators, and the energy is wasted as heat. There's kind of a jet engine looking thing in the middle that pulls 3,000 brake horsepower of traction motor heat. Slow the train down. Pretty exciting. And it works pretty well. I'm gonna go down the pit if anyone wants to look. I mean, I can walk down this side. What do you think, guys? Want to go down and take a look? Sure. All the axles on the locomotive are powered. A locomotive is a power plant on wheels. A diesel, it's like locomotive can run a couple city blocks if the power should go out. The ones that are AC up north, there was an ice storm. They couldn't get the lines back up. They took one of the locomotives, hooked it up to the transformer. We ran it in 60 cycles. They powered a hospital for about a month. But anyway, so you have a big generator driven by the diesel engine, and in here you have a GE 752 traction motor, 625 horsepower each on this unit, and so it gives you the tractor up put together. Glass brakes, wheel slip system, 1960s technology. The frequency of each wheel is communicated to a panel. That's analyzed, and the engine knows if the RPM is different than one of the wheels, takes corrective action. Engineer doesn't really have to do anything. 5,000 gallon fuel tank. We burn about, here at Crane, about $1.5 million of fuel oil a year. So, it's amazing. You'll notice, I guess, I don't have a question, but you'll see 3 or 4 or 5 locomotives together, one engineer. The locomotive has what they call a system of multiple unit control, where there's a 27-pin jumper on each end of the locomotive, and associated air piping. We can couple the engines together. It only takes a few minutes. They all operated as one with one operator. Steam locomotive, you couldn't do that. You had to pay a crew. So when the diesel electric locomotive came out, everybody jumped on board. And this locomotive was built for the Pennsylvania Railroad in 65. This locomotive costs new, minus trade-in. Locomotives are like cars. Somebody can buy a new locomotive and trade the wheel set in from another one, an old one. But minus trade-in, this was a $265,000 item, 1964. A lot of money. $5 million today.
Do you have any trouble with the knowledge base of like guys retiring, trying to work on things that are, 40, 50, 60, 70 years old? Or?
No, you know what? If you have a teachable spirit, and somebody has mechanical aptitude, you can pretty much show them what to do. Now, my forte is I know how the locomotive works as a system. Some guys I was telling them, Jerry, I guess there's a mechanical guy or traction motor guy or electrician, and the old guys, they're pretty good. They might not be as strong as the young guys, but they pick it up pretty quick. I had some really young guys that are really talented. You have to want to do this. It's not easy work. It's hard work. But the knowledge base if you're a truck person, an electromechanical kind of guy, you can learn this. Yeah, oh yeah. So.
Tom, what do you see as the advantage for sticking with an Alco versus going GE or GM or anything else over the years?
Well, I was telling you they were cheap. Nobody wanted them. Today, if you went out and bought this locomotive today, you probably spend $100,000 in today's dollars. You went out and bought a GM locomotive, or you're talking about $300,000. We have the parts space and the knowledge, and I probably have $2 or $3 million in inventory of renewal parts. So for us, it was a no-brainer. It's just kind of a little niche that we got into. It's kind of fun too, I have to admit. It's, we get a lot of attention because we have them. And as you can see, there's no light duty here. So, a couple of engineers years ago, when we said we were going to haul grain trains up to Mount Pocono, we're going to use 40-year-old Alcos, they said, there's going to be parts lining all the way from here to Moscow. That's not the case. They're doing the job. They're still doing it. And we're kind of proud of that. So it's actually a fun job. There's a whole lot worse jobs to have, So just for fun, the couplers, like here, this is something that a lot of people take advantage, they don't really pay any attention to. It's just like, take it for granted. That piece of steel there can haul 13,000 tons up a 2% grade. It's amazing and not fail. And the only thing that holds it up in place is just a small steel plate. And you just have a bump and a draft force in there that kind of wedges it in there and holds it in place. To change that, you just hit it with a forklift and it falls on the ground, but yet it pulls the whole train. So it's kind of neat,
Don, what can you tell us about the weight of the locomotive and the foundation that was needed to build something like this pit?
Well, this locomotive weighs 253,000 pounds, roughly 125, 127 tons, depending on what options the locomotive was equipped with. I don't remember exactly what Costanza did with the concrete, but I know it's substantial. And because the mine subsidence, they had to go down pretty far and make sure it was compacted. They did a lot of testing. Now, just for example, right here, where the yellow stripes are up here, this is the jacking pad. I have a 150-ton crane down at the other shop we're going to bring up here. I can actually pick up the locomotive. We have 4 35-ton whiting jacks, and this area is marked. This is down 9 feet. And this will probably handle about 50 tons in a 12 by 12 square foot area. And the locomotive has jacking pads, which are right here. So we just wheel the jack here. They're synchronized. Put the tongue here and lift the locomotive off its trucks. We would change the wheel or traction motor. But I like doing it with the crane better because it's faster. We can actually take the wheels out in about 20 minutes. It's not very hard at all. You have the locomotive's been a wreck, or there's an accident. The first thing is you don't want the wheels to become detached from the locomotive, because that changes the center of gravity, and the locomotive will want to turn over. So you have these overturning hooks right here. They prevent separation from the truck and the chassis. So to change the wheels, we take those off, disconnect the traction motor leads, take the handbrake off. I have a special sling that's rated about 80 tons, and we put it around a coupler block and just pick the end up. We roll the wheels out. Pretty neat thing. The first time I did it was kind of scary. It's like holding a locomotive in the air in Scranton and the wind starts blowing. That's like a big sail, believe it or not. And I'm in the crane, and the crane's going like this with the locomotive. A little bit. I had to run to the bathroom after that. I'm a little bit scared, first couple times. So.
What does that truck weigh?
22 tons.
Wow.
This is a little bit lighter. This is probably around 120 tons in RS3. A little bit lighter locomotive. But all in all 4-axle locomotives, regardless of horsepower, pull the same train. The only difference is that pulls the same tonnage at 8 miles an hour. That'll pull it at 18 miles an hour.
Is that the same fuel then too?
Pardon me?
The same fuel usage at those different
Now
speeds?
there's probably a little bit less. That burns 127 gallons an hour full power. That's probably about 115. So,
Wow, an hour.
Don, I'm not 100% sure on this, but I remember back in the 60s when I was a kid, 60s and 70s, there was a roundhouse here at this location, and I believe these two are D&H locomotives. Were they maintained on this spot, light running repair type thing?
sometimes. Yeah, in fact, that's a good point. These two locomotives were built for the Delaware and Hudson for this line in 1952, and the roundhouse that Pat was talking about was right here. We're on the property, right here, where the back of it, there's a foundation there, and you can walk out there later and take a look. We're right over there is where there's 12 stall. I think it was 12 stall. Does that sound
Yeah,
right?
that's right.
I think so, yeah.
I think it was a 12 stall roundhouse. I think they tore it down 1980.
I think it's amazing
81.
that they're still here, on this site, you know?
Well, I was looking for property in the valley to build the engine house for the company, and we wanted to stay in South Strand. There was no property available.
Yeah.
We looked at the Moss building over here and stuff, and we forgot this was a forest here.
Right.
And we forgot that we had this property, and I just kind of confiscated it. And I told the track department to clean it off. You know, I did the old backdoor thing. Let's see what it looks like first, and you know, and then here we are. You know, wasn't too many surprises here. We thought we would find a whole bunch of stuff buried. There was nothing here. So just a little bit of ash, a couple layers, a little bit of coal here and there, but that was it. Really pretty clean. So, well, does anybody want to go in one? We'll take a look. Take a couple. I mean, look, I'll let you guys go up, and I'll come up. Once you half of you go in the 4103, and somebody's going to 4118, and look around, and I'll, you know, I'll show you how it works. Cool. In fact, maybe. Oh yeah, Lehigh Valley, sure. Oh yeah. You know, I came here. Everybody's going different railroads. Some was Lehigh Valley, some people were Central Railroad, New Jersey, Lackawanna, some were Pennsylvania. It was funny. It was all this, kind of knew each other, never worked with each other until we came here, you know. It's kind of neat. So. Now, this is not the nicest of cabs at RS3, but like an automobile, I'll tell you this, locomotives are automatic or stick shift. This is a stick shift. Isn't that funny? Now, what you do, this is how it goes, and then this would be your dynamic brake. So let's say you're coming down the hill and you don't want to, this is the automatic brake, this stops the train, and this stops the locomotive. But let's say you're coming down, you don't want to use your air up. You're in Moscow, you're headed towards Scranton, so you just bring this lever over like this, and would register on the load meter, and you could slow the train down. If you were going too fast or getting out of control, you would bring this over to this position, take maybe a reduction to 10 pounds of air. Locomotive stops by releasing air, not by applying. You charge the train up, then you release air. That's a safety feature. If the train breaks in two, stop.
It's been that way for a long time. Like,
Yeah,
since Westinghouse invented it.
that's right. Very good. And but this locomotive, you have to shift it. So you're going along, you're pulling the throttle, and then you would be in one. At 18 miles an hour, you would lift the stump and you put it in two. No change in throttle. At 25 miles an hour, you put it in three. And you'll hear all the contactors shifted from series to parallel to reduced field. And then at 47, you put it in four. RS3s, even though they're low on horsepower, they ride great and they go like the wind. You know. These were, those of you, I don't know if any of you guys are rail fans or know anything about Alco. The 244 engine, after World War II, GM was building locomotives at an incredible, Alco was at a numerical disadvantage. So they went from the drawing board to mass production in 81 calendar days. That was not enough time to uncover the deficiency of the 244 engine. Now, Alco eventually fixed that. We can attain to this today, but it cost them a lot of sales and a lot of money. They had to come out with the 251 engine, but that hurt them commercially, and well, they're not making locomotives today. But with improvements in lubricating oil and other materials, like we talked about, the Viton instead of the Buna and rubber and things like that, you know, it's a viable locomotive today. Lubricating oil is 10 times better today than it was in 1950. Used to pull the filters out. When I first started, you have a sock. It would be a solid block of carbon. You know, that black cake stuff, you know? You don't have that today. None of that. Engines are clean. And
Do you do metallurgical analysis on the oil?
yes, yes and no. You used to do it regularly. And because the engines are so old, they were consistent, but they were high, you know. The main problem was water getting in the oil. So we could see that. So we do it. If there's an issue, yeah, I'll send them out for what they call the spectral analysis, you know, and we'll have it done, but not all the time. But yes, we do that occasionally.
And if you have multi-engines, it's all controlled from one. It's all connected electrically
right.
and it's controlled from one spot.
That's right. And they all act exactly the same. Dynamic brakes, you have alarm lights and all kinds of things. If something's wrong, it'll tell you, the bell will ring, and then you have to go back and see what engine's offline or give them the trouble, you know. An RS3, no, not this one, but the other one, this was cost reduced out. This is kind of a neat little device. That's called the engine control switch. On the original RS3, like the 4103, locomotives don't have a ground. Everything has a return circuit. If the frame gets charged or there's leakage from the high voltage circuit, a relay and a resistor picks that up and returns the engine to idle. Well, sometimes a locomotive will run, you have 8 notches here. A locomotive will run in notch 6, but it might not run in notch 8. Well, if you got a heavy train, you need everything you can get. So what you would be able to do is the affected unit, you would put that switch in 6, and whatever throttle position you call for, above that locomotive would stay at 6 and stay online and not go offline because of a ground problem, while the other engines went to 8 and did their work. It's a nice feature. That's an expensive switch, and GE costs reduce that out. But that's kind of a neat feature that you don't see on today's engines. This is the sand button here. Some of the engines we put a pedal in, and
You have a dead man switch?
what's that?
You have a dead man switch?
Nope, not on this one.
No?
Some of the engines have an alerter. There's an it wants to know if you're alive now.
Right.
So you have to do something. You don't have to hit the dead man, because a lot of guys will put their toolbox on the dead man and override the. They didn't want to be bothered. So now you have a digital readout with a light horn box that'll start making all kinds of noise, you know.
Until you touch something.
Yeah, until you touch something. So, but anyway, that's basically it. I mean, this is a pretty simple engine. Making them go is usually the easy part. Trying to stop them, that's the hard part. That takes skills, you know. You running an engine around just at the independent like a car and fine. But when you know, the first time I ran a train, this on the Delaware-Lackawanna, I was up at going under the 611 bridge eastbound, coming up through past Toby Hanna. So I came around the turn there, and it was my first solo, and I knew the terrain because you have to be qualified, and it was a real clear day. And I saw the face of the earth, the curve of the earth go like this, and I saw the Delaware water gap in the distance. Let me tell you something. My heart skipped a beat, like, you know, that's a 17-mile downgrade into Stroudsburg, you know. I better know what I'm doing, you know. So, but everything went all right, but it's just a little frightening at first, you know. The Lackawanna main line east out of Scranton is not for the faint of heart. That's why Conrail didn't want it, because it's very costly to operate. Trains had to be pushed up, and sometimes the extra locomotives had to be attached to help with braking going down the other side, like the coal train was going to Portland. It's a treacherous piece of rail. If you can run the Lackawanna main line out of Scranton, you can run a train anywhere. I think so.
How's it compare to Horseshoe Curve? I mean, that's a long downgrade.
Yeah, that's fun. I think this railroad, your curves are tighter, you know. And it's a little steeper. I think it's, maybe it's close. It's like 1.8 in some places, you know. But if you're headed west and you leave Stroudsburg and you go through the golf course at Antelope and you got a train, and the speed limit's 30, but you know sometimes you know the hill's coming, so you're into it. And as soon as you get to that golf course, it's like somebody throws an anchor out. It's unnerving, you know. And Locomotive has a minimum. See this on the load meter. You can take a look at this later. You have a green section. You're not supposed to have continuous operation in the yellow and the red. You know, you're limited. Those numbers mean the time that you're allowed, like 50 minutes and so forth, 12 minutes. You're not to exceed that on this line, and that's one reason why we have Alcos. The GE traction motors take that abuse. You can bury the load meter. Just, as long as you're rolling, just keep going.
Nice.
But I didn't tell you that. And
Sure
then,
is
yeah, it's hard.
a lot easier than a steam locomotive.
Oh, yeah.
All the knobs,
Oh, yeah.
and all those things you
Yeah,
gotta do.
you know.
We got
People,
four levers.
you know, the guys when these things were new, they went to work in a white shirt, you know, after having coveralls on. So, but anyway, you know, there you go.
Now, you can't lift one of these in here, can you?
What's that?
Your cranes can't lift one of these in here, can they?
No, that's only good for 40,000. But I could take any component, the turbocharger, the wheels, generator, a dry engine block. That crane will pick it up. You know, so careful.
There's one thing I just remember is the OSHA made obsolete.
Oh yeah.
Push pockets.
Yeah, this.
I know Bob has that.
Yeah, you notice the newer engines don't have it.
No, they don't.
Guys, Pat just brought this up. This is kind of an interesting thing. In the old days, there was a lot of rules were written in blood on the railroad. And this thing is called a polling pocket. Now today, if there's a car on this track and you needed to move it, you would go down to where the switches cross over, couple up and move it. Or if you had to kick a car, you'd couple on and let it go, and with experience, you know how much to do that. In the old days, you had a hollow steel pole, sometimes it was wood, and with rounded blunt end, it was about 8 foot long. And the brakeman would hold this as the engine were up to a car on another track. And he would pinch that pole in there, and then he wouldn't let the slack out, but the polling pole would fall out, and he'd give the car a shove on another track. Well, you know, just like there used to be footboards right here. You used to be able to ride right here. You can't do that anymore. Too many people got hurt. Yeah, you know. So a lot of things changed in 60 years, you know. The glass in the engine, even though it's an old engine, you'll notice there's like an encapsulated aluminum frame. That has to have what they call an FRA 223 glazing. Unfortunately, with the society today, kids were getting cinder blocks, tying a rope on them, and hanging them over the bridge. And the train would come along at 30, 40 miles an hour and hit the windshield and push the windshield right into the cab of the engineer or the conductor and hit them with the block. So now you have to have this glass is encapsulated, and it's pretty bulletproof, really. I've never seen one come out. I've seen them shatter it, but that was an improvement that came out in I guess in the 80s, I guess we had to do that. And then an upgrade, you had to put ditch lights on in 93, and you had to have this extra uncoupling lever, uncoupling from a car, another locomotive. A lot of, you know, if the D&H had it, they'd have to do all that stuff too, you know.
If you're looking at a unit built today versus what we're seeing here, what would be something we'd see that's different, or how what's the composition of the two when you compare them?
Well, we were talking about that earlier. One thing that's interesting is they don't make a 4-axle locomotive anymore today. You can't buy a new one. So people that have a 4-axle locomotive are keeping it, but a General Motors GP38 or General Electric, I don't even know, it'd be like a model B23 would be, I guess, close. We're talking about, this is capital investment really, what it's worth is probably not much, but you're talking about $300,000 today.
No, I meant as far as like the construction, like you said, the floor axles, like when you look at the actual engine makeup of what's sitting up there.
Oh, how?
The whole power plant, the whole house.
Okay, the only thing that's in common with a GM engine and Alco engines, they both burn the same fuel, and the similarity stops there. This is a 4-cycle turbocharged engine. The original EMD engine is a 2-cycle engine with roots blowers, or they call that naturally aspirated. Then they added the turbocharged later, but Alcos, as old as they are, one thing they're noted for, because they're 4-cycle, they're very good on fuel. I think I mentioned like that's 157 gallons an hour. A comparable EMD would be about, General Motors would be about 178, 180 gallons an hour. The efficiency in the 2-stroke, as you know, you have a port that you go by. As soon as the fuel is injected and lights off, piston's pushed down, it passes the port, you're done. On an Alco engine, the fuel ignites, the piston goes almost all the way to the bottom, then the exhaust valve opens. So you have a lot of work is done by the fuel in an Alco engine before it's expelled out the stack. Although Alcos smoke because they have a free running turbocharger, but that's where EMD would have a gear driven one. But that's the diesel engine, you know. Newer engines would be AC. This is a DC generator in here. In fact, if we come around the other side, you can see the engine on this one. Actually, this had an exhaust valve seat broke out of the cylinder head and fell on the piston, was rattling around, so we just changed it. So that's the guys that's in progress. Getting a new cylinder head. And that's the injection pump I was talking about, sitting on the cam. Now, I don't know if you guys appreciate this. A 244 engine is a dry block engine. There's no water in the engine block. The water is contained in a removable water jacket that the liner is hand pressed into with O-rings. And then it's seated in the dry block, and water enters a header, from a header right there where that little branch pipe is, goes through the water jacket, through 3 passages into the cylinder head, and then into the top header to the radiator. That was not, the problem with that is that nobody will like this. The crank pin on a 244 engine was bigger than the diameter of the cylinder liner. So on the 251, I could take the rod bearings and the cap off and pull the liner and rod up right through the cylinder. On this one, you have to put 2 little wedges and take the whole power pack out of the engine. It's a nuisance. It's a maintenance headache. But, you know, why you gotta use water treatment. They used to have, use sodium bichromate, I think. Not allowed to use that anymore, but we use like a nitrate solution. Keeps the water wetter so it doesn't cavitate the cylinder liner, and it actually rusts the liner from the outside in, and it'll fail. So, but this is 1,600 horsepower. We have a 300 cubic feet per minute, 3-cylinder air compressor, supply air. I mean, this locomotive could pump up a mile-long train in about 9 minutes, get it up to 90 pounds per square inch, operate the brakes. That's kind of neat. Pretty trouble-free, easy to work on. There's a turbo supercharger right there. That's an Alpha Model 510. This will supply anywhere between 11 pounds to 30 pounds per square inch of combustion air at full power, which is a lot, you know. And the associated devices, that's the oil strainer right there. That picks up any broken pieces from the engine so they don't go to the main bearings, you know. And then there's an oil cooler in there that cools the lubricating oil. So, you know, that's pretty much it. And Anybody have any questions?
You said this vintage is PC or AC?
This is DC,
And the newer ones are
AC. Yeah, this has a, this is kind of neat little factoid here. This has what they call amplidyne control. Amplidyne is, the definition from GE is a controlled application of a short circuit. The same system that made the turret turn in the B-17 in World War II, General Electric took that technology and applied it to post-war locomotives. So this thing is built, has an electrical system like an airplane, which sounds kind of nice, but not really. You have, everything's connected by an Amphenol plug, like maybe a 25 plug Amphenol and special. And that's okay when they were in production and you call GE, the service shop, and say, hey, I need a 110 panel. You take the one out, send it to them, and they send you a new panel. Can't do that anymore. We have to fix the panel. That's like major surgery. You know, we have to open the panel up and carefully take it apart and fix the components, check all the circuits, and then put it back in. Don't always get it right the first time. So, but that's kind of a neat factoid on the Alco, on the RS3. Good idea, but, you know, not always, in retrospect, not always wasn't the greatest thing. This little Alcos are another thing here. On a General Motors locomotive, the engine speed governor that controls the RPM of the engine is mechanically connected to the crankshaft. In 1950, Alco did it, GE did it electronically. Alco and GE were across the street from each other. They were like cousins. So all locomotives at this era were sold as an Alco GE locomotive. This will make that clear. That little thing up there is a three-phase tachometer generator, and that signal will go to one of those panels and be processed into a DC, a regulated DC current, and go to the engine governor, which is General Electric governor right there. It's not mechanically connected to the locomotive engine. It's done electronically in 1953. It's kind of neat. This is the fuel pump motor right here. And on an RS3, you actually have two pumps. This pump takes the fuel from the tank and sends it to the header for the injection pump to pick up. This is the supplying hydraulic power to the governor. So an Alco, when you hit the start button, they fire, you can almost start it with a dead battery because the fuel rack is set in some position to start the engine. Whereas a Woodward, you have to crank the engine and get oil pressure up before the governor responds. So this is a very quick governor. The train crews like that. They call them Maserati. You know, starts quick and goes quick.
Don, how many of these are in the fleet, the RS3s?
We have 4 that run right now. We have the largest fleet in the United States that still could run. Nobody runs 244s anymore. We're kind of...
So with 4 locomotives, you have the largest fleet in the country?
That's right, of this model. Yeah, there's onesie twosies here and there. Most of them are in museums. The 4068, which is down at Southside right now, we bought that. I think I paid $7,500 for it. They said it would never run again, and we got it. And there's a funny story. The engine was stuck, so the guys were all working on it, and they said, "Well, why don't we motor the generator on the batteries, from the batteries, and break the engine free and see what happens?" So they said, "We'll break something. It's junk now anyway. Let's try it." The engine broke free. So we checked some water leaks. We got the thing to run, and it ran pretty well. Me, like a dummy, I put it with these two and pushed an 85-car train up to Mount Pocono with it at full power right out of the shop. I said, well, if it blows up, it blows up. We'll try it. We get back to the shop, and they said there's water in the oil. I said, all right, one of the O-rings went. That's a normal thing for a big engine like that. We'll find out where it was, which one was leaking. So it was in the shop just like this. It was kind of quiet. Somebody hit the stop button, and the engine was slowing down. And right before it stopped, you hear, well, bang, well, bang. I said, what is that? That sounds pretty bad. So we took this door off, we looked at the crankshaft right here, and we found out that the crankshaft was a 90 thousandths undersized crankshaft. Somebody put a standard bearing in it. So there was like a 1/4 inch clearance on a journal. And that piston was going up and down, and that rod, and I just hammered up the poconos with it. And the vice president of operations was with me. He said, this thing runs pretty good, right? You know, of course I'm deaf anyway. So anyway, the thing was banging around. The old adage is you can't run a 244 because they're very fragile. Well, after that, we looked at the crank. There was nothing wrong. So we found a 90 thousandths undersized bearing, put it in, and it still runs. So they're not as fragile as you might think. So, like I was telling Pat, there's no light duty on the Delaware-Lackawanna Railroad. If it can't earn its keep, I'm too old to chase locomotives. I don't want it. Yeah.
How many operable locomotives are there?
Well, here on the property, I could probably muster about 18 if we need them all. System-wide, we have about 35.
And most of them are the others, the newer?
Yeah, most of them are century models or newer. I think our newest locomotive is 1970, and most of them are 1965, 70 vintage. You know.
So if you wanted to buy a brand new one, where would you go buy one of those?
Well, I'll probably have to go either the GE, which is now Wabtec in Erie, and it costs you about $5 million.
Wow.
Or you get one from EMD that they probably wouldn't sell you one because they're having trouble complying with Tier 4. I think it's Tier 4. Is that what it is now? I don't know. Some crazy emission standard. They can't get the two-stroke engine to be clean enough, so they haven't sold one domestically. So GE would be the only alternative. And like I said previously, you can't buy a 4-axle locomotive. You have to buy a big 6-axle like NS runs over a Taylor. And they wouldn't suit us real well. You know, we're on the Carbondale line, a lot of tight turns and customers down in little pockets and so forth and so on. That's why we have the smaller locomotives still. Railroads aren't getting rid of their 4-axle locomotives because there's none to buy. So they'll just keep fixing them and fixing them and fixing them.
So the first generation engines, the letter F on the front, is actually the front. These were
This is the front.
Longwood forward, as opposed to.
Yeah, that's a good point. Now, see, all locomotives have to have an F, identify which way is forward. That's because when you're running the train and the conductor's, you know, the radio doesn't work, he's out here and he's on this side and he's going to tell you to do this. He's going to go like this. That means ahead, this will mean back up, which is that way on this locomotive. On the locomotive back there, going like this is short hood forward. You have to know that, and you get quizzed on that. That's one thing about the railroad. Every year we have to go to school, and you get a test on physical characteristics of where you are, the rule book, maybe air brake class and engineer mechanical class or some kind of school. Roadway worker safety. Make sure you don't get hit out on the contractors. Pat, you probably went through that, right? When you were roadway workers?
Yep.
And you have to take a class so you don't get hurt. So most things are identified like that, and that's a neat point. All locomotives obviously are numbered. This is DL 4118. When you're someplace on the railroad, the dispatcher will say, "Where are you?" "I'm in DL 4118. I'm in Archibald at Brojack Siding. I want to go south." And she'll say, "Well, I can't let you go. There's traffic and whatever. Wait, there's a northbound or whatever." But the numbers are kind of know them by numbers, like a name, you know. And
So is there like a regional air traffic control for rail?
oh yeah, absolutely.
Have you had to update like communication systems in the cab?
Well, you do. This used to be a signal territory. I guess maybe some of you saw that Steven Seagal movie, Dark Territory. This is Dark Territory. You have a thing called a Form D. It's a piece of paper that authorizes you to use a certain section of track. The tower at 280 Cliff Street, right there at the edge of Steamtown, the dispatcher's up there, and they'll give you by radio an authorization form to be someplace, what direction, so forth. And she keeps a log sheet. They know where you are. and you don't violate that.
Are there GPS units in the?
No, we don't have GPS. No.
If you can't turn, I mean,
Yeah.
So how many
Can't
miles
wander
of
around.
track are you running on now, and what's your maintenance cycle for the track and ballast, or you guys don't get involved with that?
I don't get involved with that, but we're right here. We're probably route miles. It's probably about 80 route miles. Track miles is probably double that. The track, somebody's out every single day. There was somebody looking at the track every day. You get like this time of year when it starts to get cool, the steel contracts, you get a pull apart. They'll actually rip the bolts right out of the joint and separate the rail. So somebody is out there looking, they're looking at ties, looking at gauge. We have a car called the Sperry car comes, although there's some other name now. They actually magnify and or x-ray the rail to see if there's any fractures in the rail. And then there's a geometry car that comes. And they'll actually look at the surface once a year, and they'll just make sure that the track is geometrically right, you know. And if it's off, then they'll tell the office of the track department, and they put a slow order on it, everybody gets miserable, you know.
What's your top operating speed then? You can-
We're 30 miles an hour. That would be, I think we're what they call FRA Class 2 track. Class 3? 2? 2. I think we're 2.
How long does it take to get to 30 miles an hour?
Not very long. It depends. Sometimes, look, if you're going up the Poconos, you're just lucky you have forward motion. You know, you know, you're going up the hill, and you know, you're at full power. You're doing 8 miles an hour. The load meter's pinned, and the water temperature's high. The oil pressure's medium. You know, you just keep. If the bells aren't ringing, you just keep going. And then when you get up to Lehigh Summit, then you get up to track speed, you know. But sometimes you know, forward motion, that's all you care about. I mean, you know, you have a 8,000 ton train going up the hill, and or you know, 8,000 tons, whatever it is that day, and you know, that's a monumental task, really, when you think about it. You know, the head of the rail is only in contact with the wheel about the size of a dime. You know, and it's amazing how the coefficient of friction works there. And then, you know, you add a little sand and that improves that adhesion a little bit. But, you know, it's amazing what you can take up the hill. But generally, you power the train to get up the hill at some speed and not worry about the top speed until you know, you get to the top. Now, the crews, if I give them 4 RS3s and they're on the grain train going to Mount Pocono, I get a lot of flack. Because you're going to go up at 8 miles an hour. I said, well, read your newspaper or something. I don't know what to tell you, you know. Yeah, put it in 8. And RS3s, they're funny locomotives. They'll just settle down, and they'll do 6 or 8 miles an hour. You won't overload them, and they'll just go right along. They won't slip or do anything. They'll just, you know, hum right along. And they'll get up around Lehigh Summit, and all at once might take them a minute and a half to get up to track speed, you know. So they're actually fun. They're actually a nice riding locomotive too. They're kind of quiet. They're not rattle traps. It's kind of a nice locomotive to ride in. One thing we do when a train, this is a funny thing, when a train crew complains about a locomotive, the first thing we do is we add heat. They don't care about anything. 2 things a train crew cares about: that they have sand and the cab's warm. So we put 4 heaters in a locomotive. You have 2 stand-up resistance heaters that, you know, with a fan in it, and then we have 2 radiant resistance heaters on the side. And that keeps them nice and toasty, and the complaints go down tenfold, you know.
Are they air conditioned?
No, they have a nice fan, though, in them. That's something we're thinking about, though. There is, you know, ALCO, believe it or not, offered air conditioning as an option. Not too many domestic railroads bought that in those days because it cost too much money. And but all the locomotives that ALCO built for export, like Saudi Arabia and Iran, they all had air conditioning.
All that power there, you would think
Oh,
you'd put
yeah.
an air conditioner.
Well, they would put, you know, they engineered a couple systems. There was a refrigeration system, not unlike a refrigerator of the day, but they also used some of those RV ones. They put an inverter to get the current just right. They mounted it on the cab. figured out what the BTU was, and they sent them on their way, you know. Alpha had a thing called page 4. That was your optional, just like a car. You can buy options, dynamic brakes, extra mirrors. Some locomotives had what they call compound sanding. Locomotives came with different brake schedules. This would have what they call a number 6 brake. The modern engines would have a 26 brake. Well, how do you make an old locomotive work with a new locomotive? Well, there was an option. You would buy this thing called a selector valve. It would be incorporated into the order. And the Delaware Hudson, later locomotives, had 26 brake. They made sure that their locomotives were compatible. So they spent the money for the option to make the old engines work with the new engines. We do that here on the DL even today. If we get a locomotive from another railroad, we just make sure it's compatible. Our locomotives are what they call AAR, the Association of American Railroads. They have a standard, and what that would be, first of all, this thing right here, this is the 27-pin 27-pin jumper. This communicates the power, braking, and lighting, and whatever else you need between all the units. And believe it or not, there was a standard for that, but railroads didn't always adhere to that. Some mechanical officer at another railroad would say, hey, there's only one negative for 27. Let's use pin 11 that's not normally used for an extra negative. Well, on another railroad, the 11 wire was the dynamic brake alarm.
Yeah.
And then you plug it. A lot of things didn't go right. So, another thing we added was steel beam headlights. We used to have a golden glow. It was actually a gold leaf reflector with a light bulb in it. And that's all they had. They had twin steel beams at 350 watts each. You got 300 watt ditch lights down here. A lot nicer at nighttime, Don't bounce off as many cars either that way.
How much snow can you have on the tracks without it impacting the traction or anything?
You can have a lot.
Yeah.
I mean, we have a plow. It'll take, believe it or not, it'll do a 14-foot drift. But locomotive, it'll do 10 inches maybe.
At what point do you put the plow on? Or do you is it
no, we do.
winter maintenance and it just stays on all winter?
No. The plow is like a box cart kind of thing.
Okay.
I don't know if you've seen it in Steamtown. Sometimes we had it painted like a tiger at one time. Tiger stripes in the front. It's about 14 foot tall. Has a big shovel in the front that curves like this and just throws the snow out. You put 2 4-axles behind it and give it a push, and we'll break everybody's windows for the next 3 miles. You get all kinds of nasty phone calls. But ice is probably more detrimental to operation. Ice is like steel. I mean, oh my word! Sometimes if you get a time in the wintertime where maybe it's 5 degrees or lower for 3 or 4 days and it's sleeted or something, oh my word, the engine will ride right up on that ice and derail. Oh yeah, it's amazing how strong ice is. Oh yeah. And the snow, not so bad. And then the fluffy snow, locomotives consume a large amount of air. There's lots of things. There's the equipment blower, there's the intake for the turbocharger, there's the intake for the air compressor, and all that. And the traction motors are cooled by a duct here, right here. See that comes off an equipment blower driven off the generator. And sometimes, when you get that fine snow, you're taking all that snow and water and you're blowing it through the engine, blowing it on a 600 volt traction motor. Well, that doesn't always go well for the shop either, So, yeah, winter time and railroading, that's bad. That is not fun. So. That's the drains open from the engine. That's just the residual from Yeah, they weigh about 6,500 pounds each, the traction motor. The wheel weighs about 3,000, you're talking about, 10,000 pounds. So, that's that assembly right there. And then you have the journal box and all this, probably another 300 pounds there.
What kind of bearings are they now?
These are Simkin, they're called Simkin GG roller bearings. Rotating end cap. Now see, that's a funny thing. You'll notice, let's see, do we have one here? Okay, I'll show you, yeah. Now you see how, you can see this turn. The race is right there. Now, this locomotive here has a cover on it on an SKF bearing. Railroads don't like that today. And the reason for that is they used to get a thing called a hot box. I don't know if you know what that is. The bearing would overheat and burn off, and the wheel would come off. They could be doing 60 miles an hour. So now they have an infrared detector that's about a foot off the ground and looks at the journals on the locomotive. Well, obviously you can see this one, but it wouldn't read the one on this locomotive, which is an SKF. So as we go along, as the bearings fail or wear out, we're changing to the rotating end cap. Some locomotives were built with plain bearings, friction bearings.
That's when the hot boxes were a problem.
Yeah.
They were just German, they were just bushings, right?
When I've had our 3,000 horsepower engine right up at the Toby Hanna Army Depot. They had to set it out because the bearing seized up on the road, overheated and stopped and slid the wheel.
And those roller bearings?
Yeah. Oh yeah. That was kind of scary. I actually went up there with a little concoction of automatic transmission fluid and stuff called Certop from Certified Labs and poured it in got it in the bearing, kind of went back and forth and broke it free, and it limped the engine home at about 10 miles an hour. Took me a whole day to get it home, but we got it back to Scranton. And locomotives use the home heating oil too. We like number 2 fuel oil, although we're not allowed to use that now. So we have to use sulfur-free, blah, 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 you know. One thing that's bad about that is the sulfur dissolved into fuel oil, like lead did in the cars, lubricated the plunger and barrel in the injection pump. So then they took the sulfur out, the injection life went down. It's just the way it goes today. Some of the things you find out. So, but, oh, we go out there, and we can go on the 405, it's right outside, I forgot about that.
We can all stand right here on the rail, right?
Yeah,
We can do it, Todd.
we can go out there. Everybody want to go on a new one? They want a little bit newer one, go in the cab and
Yeah.
see the difference?
Sure. Let's do it.